Okay, Accelerated 2, we're gonna start off with our brand new song, All of Your Problems. Write them down. Write them down. Write them down. All right, thank you, Mr. So let's get going on these problems, okay, so that they're not anymore. So I have some general strategies here to show you regarding equations, and the reason that we're going to do them is because they will not only work for two-step equations, they will work for multi-step equations. And even when you go into Algebra 1 and Algebra 2 and Pre-Calc, the strategies that I'm going to show you will serve you well, okay? So please listen up. The first thing we always look to do is distribute. We may not always be able to distribute, but we always look for it. That's, you have a number outside of parentheses. And of course, here we do. We have a 5. So we distribute that, which means multiply. So it's going to be 5x plus 5. We did that when we were simplifying expressions. Now, we draw a line under the equal sign and we put the variables left on the left side and constants on right side. Following the rule, this is a very important rule, say it with me, over the line, you gotta switch the sign. Isn't that good? I love rhyming. Okay, over the line, switch the sign. This is known as inverse operations, at least addition subtraction part of inverse operations. So in order to maintain equality, you know, we can, if we have a positive 5x over here, it's the same as having a negative 5x over here. Negative 30 on the left side is the same as having a positive 30 on the right side, and that 5 can stay there. So it's maybe last year you learned like subtract 5 from this side, subtract 5 from this side. and you have your equality, right? And so that's all I'm doing. I'm just kind of doing it all in one step. And I really enjoy doing it this way. It makes things faster. So 30 plus 5 is 35. Bring down the negative 5x. And then divide both sides by coefficient of x. That's our other inverse operation. And that would be negative 7. So then solve. Oh, actually, I should say combine like terms. And then solve the remaining one-step equation. Right, so you'll see that no matter what they give us, so you can write down those steps, and I'm gonna clear it. Let's see what else we have. So here, okay, no problem. I'm gonna just write it. It's j over negative 2 plus 7 equals negative 12. Draw my line, and I want my variables on this side, which they are. And I want to get this positive 7 over to the other side, so I'm going to write it on the other side. It's going to be a negative 7. That's going to combine to be negative 19. So j over negative 2 equals negative 19. And now I just multiply both sides by negative 2. Cancels there. And j equals positive 38. Just love it. Okay, so wonder if that makes sense to you. So there's another distribute one. Looks like most of the ones you guys were missing so far is because of that denominator. So if you see the denominator, just multiply. But, oh, okay, we got our 2 right here. Okay. So now we have decimals and fractions. It's okay, because fractions are our friend, right? So negative 1/3 equals j over 4 minus 10 over 3. Notice I am not attempting to do this in my head at all, right? I immediately just copy down the problem. These are not things to do in your head. We want to show our work not just for ourselves, but also so we can help. So I have another tip and trick for you. The additional step that you can add to your list of 4 is for fractions, we're going to multiply all terms by the LCD, the least common denominator. What is the least common denominator of 3 and 4? The least common multiple? That would be 12, because 3, 6, 9, 12, and 4, 8, 12. 12 is the first multiple in both lists. So we're going to multiply by that number. Is going to make our life easier. When we do that, we just multiply the numerators, and we get negative 12 over 3 equals 12j over 4 minus 120 over 3. And then we can reduce. So negative 12 over 3 is negative 4. 12 over 4 is 3j. And 120 divided by 3 is, it could be 40. Now I can draw a line under my equals sign, put my variable term, there we go, over on the left side, put my 4 is going to be on that side, so positive, bring down the negative 40, that's going to be negative 36. And now I just divide by negative 3. And that would be 12. Circle the answer. Okay, so that is what to do with fractions. You have those multiplied by the LCD, you get to go. Again, we have the distribution being, well, only one person did this, but they didn't get it right. So let's talk about it. I'm going to rewrite the equation. Okay, I'm going to distribute. I'm going to multiply by the numerator there. So it's going to be negative 15 over 5. Bring down the negative 4. Simplify my fraction, that would be negative 3. So I can write negative 5p minus 3. And draw the line under the equals. Put my variable terms on the left, it's already there. Put my constant terms on the right, over the line. Switch the sign. 3 minus 4 is negative 1. And now I'm going to divide. P, and then two negatives cancel out to make a positive. 1/5. Let's just check the answer. Just in case you don't believe me. 1/5. Good job. Okay. And of course, I love how they're checking their answer. I haven't been checking my answer. I'm sorry. It should be. Okay, so let's look here. Olga tried to solve an equation step by step. So let's look. Of course, the distribute has happened first, and I already see that you can see that when she distributed, there's no parentheses, and oh, you know what? She didn't distribute. She took and multiplied by 4 because 4 times 1/4 canceled out. So that's good. That's another way to do it. We can multiply both sides by that. Okay, so you see how that works? 4 times 1/4 is gone. Okay, so now let's look at the next step. When the 9 was 24 minus 9, is that 15? Okay, so that's good. And then the last step, in order to isolate the variable, right? 1/3, we're going to have to multiply by 3. And so that will make it 1K, and 15 times 3 is 45. So she made a mistake in step 3. So just go through the problem and make sure it all makes sense. See if you can find the mistake, and if you can't, write it down. Okay, so I'll let you look for those mistakes there. Let's do this one though. Today, there were 2 members absent from the band. The present members folded 25 programs each for a total of 525 programs. What question does the 525 equals 25 times the quantity x minus 2 help answer? Okay, so let's see what, okay, so the 2 members absent. And so what would we be subtracting? I think we would be subtracting 2 from the total band members, right? Total band members. So the first thing I wanted to do there was figure out what X represented. And it represents total band members. So now when I subtract 2, that's the band members that are there. And what are we multiplying by 25? We're multiplying 25 programs each. So however many people are there, they're each folding 25 each. We don't know how many people are there, but we know that they folded a total of that much. We can do some backwards math and figure out how many band members were present. How many members are in the band when no one is absent? That's right, because we subtract 2 from the total band members. How many members are in the band when nobody is absent? That is what we are figuring out. Last, okay. All right, let's keep going here. I match the equation to the situation it represents. Kate buys 10 tickets to a show. She also buys a $5 parking fee. She spent $35 to see the show. Okay, so 35, 5, 10. Okay, but she bought 10 tickets to the show and she paid $5 for parking and she spent 35. So the amount that she spent is what it's going to equal. So right now it's one of these two. She bought 10 tickets to a show and then at a $5 parking fee. So that would be here. We are going to multiply by, what are we multiplying? 10 tickets by the price of the ticket. So X is the price of the ticket. X equals price of ticket. All right, Ram has 35 gel pens. He gives an equal number of pens to each of his friends. Sounds like division here. 1 second. Okay. And 10 pens left for himself. So sounds like this one right here, right? He's got 10 pens left over for himself, and he has 5 friends. So X is the number of pens that he can give to each friend. So I'm going to write that down. X equals pens he can give to each friend. What a good friend he is. All right, last one. Yin spends 10 hours on homework this week. Goodness gracious. 5 hours on science. Why not math? And then 35 math problems. Okay, so this is going to be the X is the amount of time spent on math in hours. All right. Let's do one more problem and then all your traffic light problems this week. There's only 2 to do. We're going to do one of them. You ready? In winter, price of apples suddenly went up by 75 cents per pound. Sam bought 3 pounds of apples at the new price for a total of $5.88. Write an equation to determine the original price per pound. Okay, so that's X, the original, or P, the original price per pound. Okay, it went up. So the original price was P, and then it went up by 75 cents. Sam bought 3 pounds of apples. So whatever that price is, we're going to multiply it by 3. And at the new price. Oh, I know it. Determine the original price. A new total. Okay. $5.88. Okay. So this is this is what it cost. $5.88. So now I'm going to distribute and I'm going to 3P and then 75 cents is going to be 152.25. And then that equals 588. So now I'm just gonna do this the old-fashioned way. I'm gonna subtract 225 from both sides. So what do we get? We get 3, 6, 3P equals 363. Divide. And then I'm gonna 3.63. 1. And then bring down the 6, 2, 1, 121. Let's see, is that the original price? See if I made it. Oh, 121. Look at that. Okay, so have a great time. These are wonderful, fun problems. So excited for you, and I will see you in class.